Hello everyone, this is BV Hermit. Today we are going to discuss the next, that is the fourth part of the atoms chapter, in which there are two important derivations are here. First one is the orbital speed of electron in a stationary orbit. Another one is the total energy of electron in a stationary orbit. These are the two important derivations in the atoms chapter. Before going to derive these two derivations, first we need to recollect some Bohr's postulates. According to first Bohr's postulate, an electron, see this is an electron of its mass m, whose charge is E, which is moving with a velocity v around the nucleus of radius r, then charge of the nucleus is considered as a Ze. Then the electron is revolving around the nucleus in a particular orbit. That orbit is called as stationary orbit or non-radiating orbit. Second postulate is an electron is revolving around the nucleus in a stationary orbit, which is the angular momentum is an integral multiple of h by 2 pi. See, electron is revolving with the angular momentum that is equal to integral multiple of h by 2 pi, where h is the Planck's constant. Then, so its expression, the angular momentum is represented by capital L, then L is equal to mvr, that is equal to nh divided by 2 pi. Then third postulate. In the third postulate, which explains an electron makes a transition. So here an electron, if the revolving electron got some amount of energy, that is excited to the higher energy level or so next orbit, then but that state is not a constant state. So immediately or within a fraction of second that will return to its ground state. While returning, which emits the certain amount of radiations or photons having energy which is equal to energy difference between initial and final states, that is E equal to h nu, that is equals to E2 minus E1. So these are the postulates of the Bohr's atomic model. Next we'll go to derivation, that is the orbital speed of the electron in a stationary orbit. See, so according to this we need to derive expression for speed or expression for velocity of this revolving electron around the nucleus. We need to derive expression for velocity. See, let us consider an electron. This is an electron. Sorry. See, this is an electron of its mass m. Its charge is considered as a minus E, which is revolving around the nucleus of its charge plus Ze in a circular orbit of radius is smaller, with orbital velocity is considered as a v. Then here the Z is nothing but it is an atomic number. Then the electron is revolving around the nucleus, means definitely there should be a centripetal force. That centripetal force which is provided by the electrostatic force of attraction between the positively charged nucleus and negatively charged electron. Hence, the electrostatic force of attraction which is experienced by electron because of the nucleus. See, so that expression for the electrostatic force of attraction experienced by the electron due to positively charged nucleus is F. See, F is nothing but here this is the force of attraction between the electron and the nucleus. So according to Coulomb's law, so F is equal to 1 divided by 4 pi epsilon naught q1 q2 divided by r square. As per that, q1 is nothing but charge of the nucleus, q2 is nothing but charge of an electron. Then charge of the nucleus is plus Ze, charge of the electron is E, hence the expression for the force of attraction is F is equal to 1 divided by 4 pi epsilon naught Ze into E divided by R square. Hence this becomes 1 divided by 4 pi epsilon naught Ze into E, it becomes Ze square, R square as it is. See, this force of attraction between the electron and nucleus, which is provided by the, so that is due to which provides the centripetal force. The force of attraction between these two which provides the centripetal force, that's why that electron is revolving around the nucleus. Then the centripetal force acting on the electron is mv square divided by r. According to Bohr's postulate, this centripetal force is provided by the electrostatic force of attraction on the electron due to nucleus. Hence, so this centripetal force is provided by this electrostatic force. That's why these two are equal. Therefore, mv square divided by r is equal to this value. That is, mv square by r is equal to 1 by 4 pi epsilon naught into Ze square divided by r square. That is, see here, so here there are some terms are cancelled here, that is r and r get cancelled. See, this r and 1 r get cancelled. That is, finally equation becomes, then remaining 1 r is transferred to LHS side. 1 r is transferred to LHS side, then it becomes, already mv square is there, so this r, if that transferred to LHS side, it becomes mv square into r. That is equal to remaining terms Ze square as it is Ze square, then 1 by 4 pi, sorry 1 divided by 4 pi epsilon naught, keep as it is. Then equation becomes mv square r is equal, that is equal to Ze square divided by 4 pi epsilon naught. This is equation number 12.9. According to Bohr's postulate, the angular momentum of electron in the nth state of orbit, that is given by, so the second postulate of the Bohr's theory, which explains electron is revolving around the nucleus in a stationary orbit. Then, so the electron revolving with an angular momentum L, that is equal to integral multiple of h by 2 pi, that is nh by 2 pi. Here that is taken here, that is L equals to so L is equal to mvr, that is equal to nh divided by 2 pi. L can be taken as mvr, then mvr is equal to nh by 2 pi. This is according to second postulate, where n is orbit number, that is first orbit, second orbit, third orbit, like this. Then now dividing this equation number 9 by equation number 10. So this is equation number 12.9 divided by equation number 12.10. Then, so it becomes, see here, LHS side mv square divided by r divided by mvr. So mvr and mvr get cancelled, remaining term is v, 1v we wrote here. So 1v we wrote here. Then next on the RHS side, that is Ze square divided by epsilon naught, 4 pi epsilon naught is here, divided by nh by 2 pi. Here in which some terms are cancel each other. here in the RHS side, Ze square divided by 4 pi epsilon naught divided by NH divided by 2 pi. So 2 pi and 4 pi. So 2 pi 1s are 2 pi 2s are. Then remaining terms Zd square keep as it is here. Then 2 pi becomes now 4 pi becomes now 2. Then epsilon naught keep as it is. The remaining one is, that is H. NH here. So here N is we wrote here outside. Then remaining H is remaining here. That's why the final equation of the expression V is equal to 1 divided by N into Z square divided by 2 epsilon naught H. This is equation number 12.11 is taken as, so expression for velocity of the revolving electron around the nucleus, or this is an expression for speed of the electron revolving around the nucleus. That is V is equal to 1 by N into Z square divided by 2 epsilon naught into H. So here which is shown in the box. So that is an expression for velocity. Next derivation is the total energy of the electron in a stationary orbit. See here, according to Bohr's postulate, electron which is revolving around the nucleus in a particular stationary orbit, so with a particular energy. So now we want to derive the total energy of the revolving electron. Let us consider an electron of charge minus A, its mass is m, which is revolving around the nucleus of charge plus Ze. Then electron is revolving around the nucleus with a radius is r. Then see here, electron is moving with a velocity, particular velocity v. Because of its motion, the electron has kinetic energy. We know the definition of kinetic energy. Kinetic energy nothing but energy possessed by virtue of its motion. Here electron is moving in a particular orbit, that's why there is a kinetic energy. So because of electron is it in electric field. See here, this is a nucleus. So nothing but which is a positively charged one. So if there is a charge, definitely there should be a space around the charge, there should be a electric field. If another charge entering into that field, so which experiences a force, if that is within the field around the nucleus or somewhat other charged particles. Like that, here this electron which is present inside the electric field of the nucleus. Nucleus means it is a positively charged body. So the electron which is present inside the electric field, that's why, so here which experiences a force, then definitely there should be a potential energy. See here, once again I am explaining, because of its motion the electron has kinetic energy, that is the first thing. Because of electron in an electric field due to this nucleus, so it has a potential energy. This revolving electron has also a potential energy. The total energy of electron is equal to, that is we know the general formula, the total energy is equal to sum of its potential energy and kinetic. The electric potential, we know that from the second chapter we learned that electrostatic potential, that is formula is equal to 1 by 4 pi epsilon naught q divided by r, that is electric potential due to point charge. Like that, here this is the concept of electric potential at a distance r from the nucleus. See, electric potential here at point from the distance r, so that electric potential is equal to 1 divided by 4 pi epsilon naught Ze divided by r. Therefore, the potential energy U of the electron at a distance r from the nucleus is, so see here the general formula is general formula of electrostatic potential energy is equal to 1 divided by 4 pi epsilon naught q1 q2 divided by r, like that. So if you apply it to this one, so that is equal to u is equal to 1 by 4 pi epsilon naught. Q1 means charge of the nucleus, that is Ze. Then Q2 means it is the charge of an electron, that is taken as a minus E, then divided by R, that is distance between electron and the nucleus. This is R. This is the charge of the nucleus Ze. Charge of the electron is considered as a minus E. Hence, this becomes U is equal to 1 divided by 4 pi epsilon naught Ze divided by R. Then if you multiply these two, it becomes minus E into Ze becomes minus Ze square. Then U is equal to 1 divided by 4 minus 1 divided by 4 pi epsilon naught Ze square divided by R. This is equation number 12.13. See, the kinetic energy of the electron K is, we know the general formula of kinetic energy, that kinetic energy is equal to half mv square. This is a well-known term. Then the centripetal force acting on the electron is, mv square. This is also well known. The electrostatic force of attraction experienced by the electron, the revolving electron, which experiences electrostatic force of attraction, because this is a positive charge, electron is negative charge. Due to electrostatic force, these two charges are attract each other. That attractional force F is equals to, we know the formula, that is 1 divided by 4 pi epsilon naught q1 q2 divided by r square. As it is, q1 means charge of an nucleus and q2 means charge of an electron. As per that, F is equal to 1 by 4 pi epsilon naught Ze into E divided by R square. Therefore, Ze into E becomes Ze square. Then 1 divided by 4 pi epsilon naught Ze square divided by R square. According to Bohr's postulate, this centripetal force is provided by the electrostatic force of attraction on the electron because of the nucleus. This is already, I told that an electron is revolving around the nucleus with a centripetal force. That centripetal force is provided by the electrostatic force of attraction between positively charged nucleus and negatively charged electron. Then, so the above equation becomes, see here, this electrostatic force which is provided by centripetal force. Therefore, the centripetal force mv square is equal to electrostatic force. mv square is equal to 1 divided by 4 pi epsilon naught Ze square divided by R. That is, so R get cancelled, 1 R. Then see here, there is one more R is remaining at the denominator side. Remaining terms, mv square keep as mv square, then that is equal to 1 by 4 pi epsilon naught as it is Ze square divided by R. 1 R is cancelled here, that's why remaining 1 R is here. Next one is, now substitute this equation, see here. So now we need to substitute this value mv square value in equation number 12.14. See here, in the equation number 12.14, there is k is equal to half mv square. Instead of mv square, we need to substitute this value, that is 1 by 4 pi epsilon naught Ze square divided by R. Hence, the k is equal to half as it is. See here, on substituting, then kinetic energy k is equal to half as it is. In place of mv square, the value is equal to 1 by 4 pi epsilon naught Ze square divided by R. Hence, see here, 1 by 4 pi epsilon naught Ze square by R keep as it is, 1 divided by 4 pi epsilon naught Ze square divided by R, but this 2 is taken here. That's it. This is equation number 12.15. From equation number 12.13 and 12.15, see, in the equation number 12.13, this is a potential energy. The potential energy is minus 1 divided by 4 pi epsilon naught Ze square by R. But in equation number 12.15, this is a 1 by 4 pi epsilon naught Ze square divided by 2R. Now, So from these two equations, the total energy of an electron can be determined. That is equals to the total energy is equal to sum of kinetic energy and potential energy. The kinetic energy value is here, that is 1 by 4 pi epsilon naught Z square divided by 2R. Then plus U means potential energy. Potential energy value is minus 1 by 4 pi epsilon naught Z square divided by R. So we substituted here, that is a minus into plus becomes minus, then minus 1 by 4 pi epsilon naught Z square by R. This is the value of potential energy. Then after simplification, some constant same terms are here, keep it outside. 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught here both sides, and Z square also here and here, that's why keep it outside. Then R and R also having in both sides, that's why 1 by 4 pi epsilon naught Z square divided by R is a common term which is keep it outside. Then it becomes 1 by 4 pi epsilon naught Z square by R is outside. Remaining here in this equation, there is 1 by 2 is here, we wrote here, minus, so if we keep this outside, then remaining term is only 1, then I wrote here. Then on taking this LCM, so half, so first half minus 1 means it is a minus half. Then so we need to multiply this minus half to multiply to this equation, then it becomes minus into this one is minus of this, hence minus 1 by 4 pi epsilon naught 2 Z square divided by R is here, into minus of means minus 1 by 2 we took here. This is equation number 12.16. Now we need to substitute the value of R here. Hence this expression for radius, the expression for radius of orbit R is equal to n square into h square epsilon naught divided by pi m Z square. This is already learnt in the third session of the atoms. R is equal to, sorry, the expression for the radius of the orbit is R equal to n square h square epsilon naught divided by pi m Z square. Substitute this value in the value of R. Hence, on substituting this value in the equation number 12.16, here after this becomes 1 divided by 4 pi epsilon naught Z square divided by 2 keep as it is. Instead of R, we wrote this value of R. That is actually n square h square epsilon naught divided by pi m Z square, but that is in the R value in the denominator, hence it becomes reciprocal. Hence pi m Z square divided by n square h square epsilon naught. On simplification, it becomes, so this value becomes 4 pi epsilon is here, pi and pi get cancelled, then 4 into 2 becomes 8, we wrote here, 1 divided by n square, see this is an n square, first we write this, we wrote this term, minus keep as it is, 1 by n square we wrote as it is, pi get cancelled, then z into z it becomes z square, e square into e square becomes e raised to 4, m keep as it is, then 4 into 2 becomes 8, so h square keep as it is, epsilon naught into epsilon naught square, pi get cancelled. So this is an expression for total energy of the revolving electron in the nth orbit. E is equal to minus 1 divided by 4 pi epsilon naught into m z square e raised to 4 divided by 8 h square epsilon naught. This is equation number 12.17. This is an expression for total energy of the revolving electron in the nth stationary orbit. See, this is given here. So this is for the expression for total energy. If in particular for a hydrogen atom, Z value, atomic number value is 1. Hence, so if the Z value is 1, above equation becomes E is equal to minus 1 by 4, 1 divided by n square as it is. Z of without Z, that it becomes, if the Z value is 1, it becomes m e raised to 2 8 h square epsilon naught square. Then after substituting these values, it becomes minus 1 by n square, where n is the orbit number. It may be first orbit, second orbit, third orbit, like that. Then remaining these terms are constant terms, where m is mass of the electron. Mass of the electron value is 9.1 into 10 raised to minus 31 kg, and E be the charge of the electron is 1.6 into 10 raised to minus 19 coulomb, where H is the Planck's constant. Its value is 6.626 into 10 raised to minus 34 joule second. Then epsilon naught value is 8.854 into 10 raised to minus 12. So that is these are the values of this constant. After substitution of these values, will get the energy value is minus 1 by n square into 13.6 electron volt. So this is the concept of total energy of the electron revolving in the stationary orbit, and this is the expression for the total energy of the electron revolving in a nth stationary orbit. Thank you.